So I'm going to talk about, actually, I like Ceph Days so much. Was anyone here at Ceph Day Berlin in 2018? Berlin? Great. Because this is, because I gave this same talk then. And it wasn't on YouTube, but I want to get it on YouTube, that's the thing. So for those who don't know me, I'm CTO at Clyso. I'm on the Ceph Executive Council, been with the Ceph Foundation since the beginning. And before, not too long ago past, I was running Ceph at CERN for the past decade, and chief IT architect at CERN, and then I'm on sabbatical doing this now. The motivation for this talk is about this picture. It's something like a picture of me in a previous life, and it's something that, it used to be what Ceph Days were all about. It was about stressed out Ceph operators that would be in this position, okay, and we'd have kind of group therapy sessions and we'd share stuff. So this is that kind of talk where I'm going to share that kind of PTSD experience. Because this was and has always been a kind of position that Ceph operators are in, and I'll get into more detail. So over the last year, I met lots of Ceph operators like that, and in different kinds of challenging situations. And me with this like weird, should be longer beard, share them some obscure tool. I say tool because I learned at CERN that you shouldn't call these things scripts because that's like derogatory somehow. The data distribution for all of the like Higgs boson data distributed globally to 200 supercomputers around the world is like a 100-line Python script, okay? And but you can't call it a script, it's offensive. It's a tool. It's a program, software. So anyway, I have some scripts like that, and lots of people, they run this, and then they're so surprised. And it's like, it's magic. Wow, it like saved my day, and they can go with their kids on the weekend. And after talking about this, also at Ceph Day Berlin and repeatedly and on the mailing list and stuff, I asked myself, how can this happen? How can people not know about this sort of stuff? And I think it's because it's related to like 5 or 6 or 7 years ago, we as a community decided like not to talk about the complex things about Ceph anymore. We should like, Ceph's too hard. And it's because PGs, like let's not talk about PGs. It's just, people don't want to buy it if there's PGs. So we stopped like sharing experience and like understanding how Ceph works. And then we wrote a bunch of code to like hide all of that. And we wrote all this like automation. The automation that takes that jump across, that leap of faith jump for you. I mean, before you would think and be like, can I push the button? But anyway, we stopped learning it. So I'm going to talk today about how Ceph works, why we have PGs, what is Crush, what is this thing called Upmap, which is my favorite thing ever about Ceph, and how are these things all so important when you're operating a large Ceph infrastructure, okay? So I'll get into it now. We know Ceph stores objects, but how does it decide where to store them, and how does it remember where to store them? This is the picture from one of the original Ceph introduction talks, okay? You have objects, and you want to store them on a cluster, and the cluster has disks, right, OSDs. This is not a 101 class, this is like a 201 class, so I think people know about OSDs. Ceph introduced this thing called placement groups. And a placement group is a collection of objects managed as a single unit. It's just like, put your apples in a basket, and now you can carry the basket. You don't have to carry the apples individually. You have to remember where all the apples are. How do we actually place the objects then? Everyone has heard of Crush, and they think it's Crush, but actually we don't use Crush to place the objects right away. First, we put the objects into a placement group, and we just randomly, uniformly hash the name of the object and put it in a placement group. Every placement group gets pretty much the same number of objects. It's pretty good. And then we use Crush, this magical thing called Crush, to put the PGs onto the OSDs. Voila. So this is like two-step placement. Now, why do we have this thing in the middle called PGs? Why don't we just use Crush to put the objects directly on the OSDs? Why do we first put them in these baskets? And there's like a really interesting way. There's lots of reasons why this is the case, but there's a really interesting reason, like statistically, mathematically, why. And it's because if you did that, if you just took like an object and placed it directly with Crush onto the OSDs, you'd effectively like peer every OSD with every other OSD in the cluster. And what that would mean, this is a disaster for high availability. It would mean that any concurrent failures anywhere would lead to data loss. For example, like if you have a large cluster, 5,000 OSDs, you can have like failures, read failures like anywhere all the time. On a scale like that, disks are failing all the time. There's 125 billion, 5,000, pretty much the power of 3, 125 billion ways that you can combine those OSDs, right? And any of those would cause a failure. But because we only peer with roughly like 100 other OSDs, the way we group things into PGs, the vast majority of those concurrent failures don't matter. Only the concurrent failures where there's a PG there, that 3 OSDs together, those are the ones that are relevant for data loss. So this is actually like not, I don't think this is talked about that much, because people, after Ceph was invented and Sage did all the awesome research and published it all, like I found this recently, 7 years later, someone published a paper called copy sets. And copy sets and placement groups is pretty much the same idea. This is a snapshot from this paper, Usenix 2013, and they had this brilliant idea, hey, let's not just like randomly put all the objects or the files onto all the servers, let's like group them and then put those groups onto the disks. They called that, so this plot shows, it's kind of before and after. It's the probability of, if you have 1% of your disks fail at the same time, what's your probability of data loss? And for like normal things like HDFS, RAM Cloud, the way that Facebook was doing their storage with random replication, it's very, very quickly you lead to 100% data loss. But as soon as you start doing copy sets, aka PGs, it becomes like very infrequent that you have data loss. So that's an important, interesting thing about Ceph, why Ceph is cool. So then, okay, what's the purpose of Crush? Since the beginning, I think Crush was like the secret, the magic secret sauce of Ceph. What does Crush actually do? It gives us the language. It's a few things, right? It gives us the language to describe our infrastructure. We can learn about failure domains, things like that. We can implement failure domains and whichever kind of rule that you want, placing data across servers, racks, rooms, also for erasure coding, it's that language. But it's also importantly really fast, and the Crush maps, the thing that you describe that is very tiny, so you can share it between the clients of servers. And what does all that mean? What's the reason for all of that? The reason is because conventional storage, legacy storage, could do all this as well, but it had to keep a big database of those locations, right? And that's why Ceph is exascale and all of that. So just reminding what we know. But something interesting about Crush is that it's imperfect. It's really good. Crush is awesome, right? Sage used to say everything was awesome. Crush is one of those things that's awesome. But it doesn't, if you just use Crush alone, it doesn't lead to a balanced cluster. Like it's impossible with Crush to have uniform data distributed across the cluster. And this is something we solved in Ceph a long time ago, but I'm kind of repeating the history of this. And there's 2 reasons why Crush leads to imbalanced OSD utilizations. One of them is, oh, by the way, why is this a problem? It's a problem because we don't keep that database. We'll just put objects wherever the algorithm says they should go, and it means that if you have one disk full in your whole cluster, the whole cluster is full. So you really can't have, you need to have things balanced. Another way to say that the cluster's full thing is that if you've bought 100 petabytes of disk storage and you just install Ceph, balance thing, you've lost 20 petabytes of capacity out of the box. That's real. There's also bottleneck reasons, of course. Okay, why does it happen? One is basic statistics. We recommend everyone to have 100 PGs per OSD, and because we're randomly assigning things, the expected standard deviation when you have 100 PGs per OSD is around 10% standard deviation. So you'll have 10% in the variance of the OSDs with each other, which means your most full and least full is going to be 20% away from each other. That's where I got that 20 petabytes number from. There's also a similarly interesting reason that Crush is broken. It's like even more mathematical. It's called the Crush we call it the Crush multi-pick anomaly. And what this is if you have uniform cluster, all the OSCs are the same size, then this isn't a problem. But as soon as you have OSCs with different sizes, then there's like a flaw in how Crush works. Because we use the same, suppose you have like a 5 terabyte OSC and a 1 terabyte OSC, we're using that value 5 and that value 1 for the first replica, looks good. And then we use it for the second replica and the third replica, et cetera, for erasure coding, and that's wrong. Like, that's the wrong values to use, because actually when you remove those OSCs from the choice, their relative weight should change. So Crush will never get it right on clusters with mixed sizes like that. So those are two interesting reasons. And that's all why, okay, this is summarizing, blah, blah, blah. Up to now, PGs are great, Crush is great. Crush is a little bit imperfect for these reasons. So maybe like people think, okay, why don't we go back to that legacy idea, have a database of where things are, do some post corrections, just store where the PGs are. It would be pretty small. We only have, even in the largest clusters, we only have a few tens of thousands or maybe 100,000 PGs. So even a few kilobytes, you could store a database of where everything is. And you could then, if we had like a database like that, you could optimize it according to any heuristic you want. I know Andros wants to do that kind of thing. So that's the summary up to now. Of course, we did this. This is what Upmap is. It's that database of where the PGs are located. Okay, so the commands are shown there, so you can see what it is. But it's just to explain. I hope I've explained what is Upmap and why we got there. In the end, how it was implemented wasn't exactly a database, but it's like a final filter in that two-step data placement that we had. We added a third step, or I call it like a 2.1 step, where you just do a small correction at the end to fix the few errors that Crush had. So 2.1 step data placement, I call it. We just add Upmap there, boom. So you have the object name, you calculate something based on its do like a random, say, object name mod 1000, and then you get a PG ID, you use Crush to map that, you use Upmap to tweak it just a little bit, and then you store it in the cluster. That's how that all works. So, how is it used? The reason that we used it was to develop the balancer. So Upmap can be used so there is an internal component in Ceph called the balancer. This is the problem it solves. People will say, oh, Ceph DF, my disk free on my cluster, it says 50% overall, but my CephFS data pool is 75% full. Why is that? It's actually it's because the pool's imbalanced, and one of the statistics is reporting you the overall space, but CephFS data pool notices that, oh, the most full is actually 75% full, and it's going to get there soon, so you better balance it. We added that automation, a thing called the automatic balancer, several years ago, probably 6-7 years ago, Luminous release, I think. And it uses that database, that Upmap thing that I introduced, to move the PGs around from the most full to the least full OSDs. And actually it works. In, I would say, 99% of the clusters and use cases and scenarios, it just works. TLDR, just enable it. There's the settings. There's a couple of, I think the most important on this is the last line here, up max deviation 1. We should just make that the default. I don't know why it isn't yet. And just turn it on. And large clusters will recover several petabytes of capacity using this, and performance will be balanced, and everything will be great. That's the end of the talk. Is that the end? No. Actually, oh, yeah. Someone, since there's some history, I think maybe one of the next Ceph days, I'll just do the best of all the previous Ceph days and best of the previous cephalocons, because this is actually a video from Tom Byrne from RAL in the UK, Rutherford Appleton Lab, and at Cephalocon, probably in Barcelona, he presented how the Upmap balancer looks in practice. So this is like a histogram, the OSDs, how many OSDs are 40%, and you can see that range. This is what I'm talking about. Out of the box in Ceph, you'll have a range from, in his case, it was from 40 to 80% utilization. So they actually were wasting 40%. And then let's just click play. It should work. Yeah. Enable the balancer. I think this was a period of maybe a week or two, and it just squeezes things. And yeah, this is one of those like top videos. Let's watch again. It was so cool. So satisfying, right? I mean, when we saw this, it's like, yeah. Ooh. Oh, yeah. All right. So that, thanks to Tom. Okay. Okay. Yeah, slightly uncomfortable. Well, we can watch it again later, okay? I'm not going to do it a third time. How do I get to the next slide now? There we go. But wait, there's more. Okay. So as soon as when we did this Upmap thing, it's like some of us, we were like, wait a minute. We could do crazy things with this Upmap tool. Like this can actually be useful for some of our other like really big problems. Sure, maybe, okay, management is losing 20% of capacity. That's not my problem though. My problem is I need to add capacity. I need to replace servers. I need to change placement rules. I need to change weights. Back then, and probably again someday, I need to change the tunables in Crush. There's lots of things in Ceph where like you have to click a button, and that goes back to that picture I was showing at the beginning. It's like you have to click a button, and you don't know what's going to happen. You know a lot of data has to move, and you're like, when do I, like, okay, I'll do it. And then you know you got to just watch the cluster for a while. Yeah. Moving lots of data can last several days. Unpredictable impact. No undo button. Okay. Yeah, that's the picture. Wow, I should have looked at my own slides. Okay. Here's how we do that in practice. So, you know, nowadays we do Ceph orc apply OSD, or if you want to drain a host, you can reweight subtrees, Ceph OSD crush tunables. There's lots of commands that do this. And normally what happens after this is you get some kind of line that says, you know, there's this many remapped PGs, so many billion objects are now misplaced, and you get this nice progress bar that's awesome, right? But it's like, says predict 6 weeks or on a good, yeah, sometimes, right? So, and you wonder, should I just wait those 6 weeks? Or should I call Dan and run a magic script? Well, if you call Dan and run a magic script, you'll get health okay like now, right now. Okay, so here's an example. This is one of those, 23% in this case. What if we could, so objects are misplaced. That means PGs are in the wrong place. Why don't I just use that Upmap database thing and tell Ceph, no, they're in the right place. Right? You see what I mean? Just use the database and say the data, Ceph thinks the data has to go from here to here. I'll just tell Ceph to stop thinking that. Just keep it there. And then I can, you know, go home. So that's what we did. That's what we did. So I wrote this script. It does a magic script. It creates all those Upmap things. Health okay. It worked. And is this cheating? No, it's not cheating, because we have that balancer thing. The balancer thing, what is its job? It has one purpose in life. It sees big OSDs and small OSDs, and it makes them the same size. So if I just added some empty servers, they're empty, right? So they're not the same size, but I have health okay, but the balancer has lots of like automation and really like good heuristics in there to do things gradually in a like smart, safe way. So the balancer like does my job for me in a way that I can also pause it and like I can control it better. I can drive it. So that's what the whole purpose of that script was. No leap of faith required. Upmap gets you there. Yeah. So what is that magic script? Okay, Alex, I wasn't going to use ChatGPT to generate graphics, but then, yeah, I had to. So there's the magic. But I didn't have time to say, no, it's not that kind of script. But that's a script. A scroll is also a script, right? And it has an octopus on it. It's called Upmap Remapped. You can just run it. It's safe. If you like the output, you just pipe it to bash, and it'll do stuff. DigitalOcean, I think maybe they saw it and made it better or had the same idea and didn't notice, but they have something called PG Remapper. It does the same thing. So great minds think alike. Yeah, anyway. And yeah, we want to contribute this as a it just works feature of the balancer. I think I have an idea. I think there's a way to make this like built into Ceph. Anyway, one more thing. Because yeah, I think you were referring to Ceph Day Vancouver, right? At Ceph Day Vancouver, I think my whole talk, that was like when ChatGPT was new and everyone was excited, also last year. And we were thinking, yeah, why don't we just get ChatGPT to run our Ceph clusters for us? That would be great. So that's where I asked it to generate like a Ceph conf optimized for performance. And it output total nonsense. And actually it was dangerous. It said, the first thing it said was, Mon, allow pools to be deleted or something like that. So it's just nonsense, right? Okay, but I haven't given up that dream. I haven't given up the dream. Like, we need to do it. We're working on a Ceph Copilot. Yeah, totally. Josh, my student, he's like working on the chatbot part. He's working on it. We can do it. So we have this thing, this Ceph Copilot assistant. Okay, it's not all AI stuff, right? It's also, we have a thing called the Ceph Analyzer that checks that your stuff is complying with best practices, using tools like Upmap, Remap to do planning, maintenance, debugging your cluster, maybe the chatbot if it gets there to a version that works well, and it's going to be all in our GitHub pretty soon. Yeah, this is a screen, the bottom is that like screenshot from Ceph Day Vancouver. It was just scary. And since there's time, okay, one last thing. The funny stuff is over. We were supposed to have my other colleagues joining from Clyso, because we're working on lots of different fun things to help Ceph operators, and one of the other things that they're working on over in Europe is a tool called Chorus, and that's all of these things come from when you notice what your customers are struggling with, and one of them is migrating data around S3 clusters. So we have this open source front-end, S3 front-end Swiss Army knife called Chorus. It's a course, like a choir of object storages, right? And you can watch the video from FOSDEM to see it introduced, and it's Apache 2 licensed, and it's really smart, kind of like transparent traffic routing, data migration, bucket replication, whatever you want between any kind of S3 compliant backends.